So again, my name is Christian Sasser. I'm the astronomer in charge for iTelescope, and today I have the pleasure of once again introducing Rowland Archer, who's going to talk about Voyager to us. So Rowland, welcome to another show, and thanks for being with us. It's all about the advanced version. I myself use Voyager very frequently now, since several months, and I also use the advanced version, so I can't wait to hear more. Rowland, welcome.
Well, thank you, Christian. It's great to be here. It's always fun to do these webinars, and especially with such an international audience, people from all around the globe. I'll do my best to keep you awake. I appreciate those of you who are joining us late here. Maybe you've had already some dinner and a couple cocktails, so maybe you will be a relaxed audience, and hopefully we'll stay awake.
Yeah, Rowland. So it's exciting. It's about the advanced version this time, and you just tell me. Yeah, someone says already, I love Voyager Advanced. So well, that's great. There's some people
Good to hear.
So yeah, why don't you get straight to it and
sure.
And let me know when you want to run your polls. And
yeah, I added a note on the slides because otherwise I'll get all okay. going here and I'll forget. So.
Okay.
Yeah, so this is very exciting. Voyager Advanced is a great product that I've been excited to use in my own observatory since the beginning of the year when it was in beta. Let me share the screen here and see if we can get PowerPoint to cooperate. It always wants to start up in presenter view. All right, so do we have my opening title slide up there, Christian?
It's perfect. Go ahead.
Yeah. All righty, great. So yeah, so last time we came on here and we did talk about basic Voyager, and very nicely Christian took the effort to upload the presentation from before to the YouTube channel. Do you want to say a little bit about that, Christian?
Yes, thank you. So this was a great initiative. So also I wanted to say thank you for those who are helping. We now have an iTelescope. I just have to get the correct link. 1 second. I hope this is the correct link. Sorry, let me just get this back again. Now I lost it. Here we go.
Yeah, well, you're looking for it. So yeah, we did a webinar back in February on Voyager Basic, and I thought it would be good. I'm not going to go over that ground again, so it'd be good just to have a link to it, and it's been uploaded to the channel.
Yes, and by the way, please subscribe to this channel. So I've got 3 very kind members who are helping build up this channel. So in the next weeks, we're going to populate this with all the relevant major webinars that we've had in the last it's almost been a year now. So they'll all be uploaded on there. So please subscribe to this channel. We'll be populating it and putting information and so on. And this will also be used for live webinars in future. So thank you. Go ahead, please.
Okay, great. Yeah, so the agenda this afternoon, evening, wherever you are, is very quick look at my own background and a bit on Voyager at large. And then we'll talk about automated scheduling, which is really the key feature in Voyager Advanced. And there's only about 10 or 12 slides we'll go through quickly, and the bulk of the time will be a demo of Voyager Advanced, and particularly the Robo-target feature. And we'll take questions at the end, unless there's something that is urgent. You can break in, I guess, in the chat, or however Christian wants to handle questions. I don't have the chat up here now while I'm presenting. So my background, like many people, I started as a kid with a Newtonian, and I'd actually got an undergraduate degree in physics and astronomy, but then I went over to the dark side into software. I've spent most of my career as an executive in various software, hardware, and cloud services companies, and always have been a developer, even while I was doing the management jobs. Then about 6 years ago, I got back into astronomy by finding a small Newtonian scope at a used goods store, and of course that quickly graduated to all this junk you see here now. So there's a way with this hobby of accumulating hardware. And then 3 years ago, I moved out to a little darker site, not as dark as some of the wonderful iTelescope sites, but dark enough that I can finally see the Milky Way most nights again when it's not cloudy, which is very nice. I don't think I've lived anywhere since childhood where I could see the Milky Way. And the good folks at Backyard Observatories built a roll-off roof observatory for me. So I have 3 piers running every night. And there's a Dobsonian here as well. And those three peers are all run by Voyager. And since January of this year, they've been run by Voyager Advanced, which gives me all night unattended imaging, which is good because I like to sleep. So briefly, Voyager is astrophotography automation software. So those of you who are, most of you are probably familiar with it, but imaging automation, it's almost like having a smart helper who will operate your system for you, and ideally hands off from dusk to dawn. So I just sit back and watch Voyager Advanced do the work to capture my data, rather than having to sit by the scope and nursemaid it through the night. The emphasis that Leo, the author of Voyager, has always had is on reliability and quality. And it also is focused on deep sky objects. So this is not a planetary imaging software. This is deep sky focused. So one question now, there are plenty of products in this space, SGP, NINA, ACP, and others, CCD Commander. Who I'd like to run a quick poll to say who actually is using automation to run your setup now. Christian, over to you, poll master.
I hope I got the right one.
You do.
Okay, good.
And then we'll ask a little bit later about using unattended imaging automation, which is kind of the next step. I did quite a bit with various pieces of automation software. I even put a survey up on my blog where I compared the features of all the major packages, because when I went from just having one scope to having three running all night, my needs changed a bit. And I was looking for a good value. I was looking for reliability, and something that I could extend. And at the time that I started using, and go ahead, Christian, interrupt me when you're ready to show the results. Otherwise, I'll just keep rambling here.
Yeah, almost. Just give
okay.
me a second.
So yeah, quickly, when I started going from 1 to 3 scopes, I realized that the cost was going to be a factor, but I also wanted reliability and ease of use. So okay, we got some results here. Great. So it's almost exactly split in half.
It's almost like elections, isn't it?
Yeah, very interesting. Oh boy. we'll stay away from politics here.
I know.
So that's good. Okay, that's good to know. So as I mentioned, Leonardo Arazzi is the author of Voyager, and it's kind of a unique individual because he's both an APOD winning astro imager, but he's also a professional developer of software, and his focus has been on the real-time software industry, where reliability is super critical. And his initial focus, because he didn't live at a dark site, was to have something that he could travel to a dark site with his family, set his scope up, start it running, and know that when he finished the night in the morning, he actually had results, good results. So he didn't have to dedicate the night to sitting next to the scope. And that's been over 9 years ago, and now Voyager is being used worldwide, and it is still being used by people who travel and just want something to set up and break down every night, to people like me that have a backyard setup, as well as professional observatories and even some rental scope operations now. So I'm not going to go through these in detail, but these are features that in various subsets you'll find in most imaging automation software. So you can read them yourself to see what's here. Some of the unique things, I think, are the drag script capability. So, and I'll show you in a second how that works. But in addition to being able to sit next to your scope with Voyager, push buttons and make it do things, you can create an all-night automation script that's totally customized to your use. And again, the key is reliability. I've now used this almost 4 years now. And I've only lost data a couple of times, and those were my own fault. So it really is very, very solid. There also are a couple of add-ons available. There's a product called Viking, which is a way to integrate with your control switches, sensors, and relays if you have an observatory setup. Another nice feature is an array setup, so you can have more than one scope running on a single mount, and it'll make sure that as it's doing things like dithering, that it doesn't start dithering the mount in the middle of taking a shot on one of your multiple scopes. And there's also a distributed emergency event manager, because like me, if you have an observatory with more than one scope in there, you really don't want them all competing to open and close the roof. So this centralizes that control in a master-slave fashion. All right, so that's about all you're going to see on Voyager Basic. If you want more, again, go back to the link we shared earlier on the iTelescope webinar channel. So there's more than one way to look at automation. Within Voyager, there is a sort of a point and click called On the Fly panel. And from this panel, you can do a lot of things. You can find a target. You can make the scope slew to the target. You can create and run a sequence. You can do an autofocus. So this is, again, it's handy to have this available just because you may want to be doing some things manually, but this is not, where the magic happens in terms of the unattended automation. There's also a fundamental unit called a sequence in Voyager. And this is where you define for a single target the shots you want to take, the filters you want to use, the exposure lengths, binning, gain and offset if you have a camera that has settable gain and offset, number of shots, and so forth. And then a whole series of aspects of your imaging train around what to do when you start up, cooling, whether you want to do a plate saw pointing to get exactly pointed to the target, rotator settings, and so forth. So all the things you might do in running a single target through a sequence are defined on this sequence panel. There's also a research and survey type of sequence. So this is very much like the previous one, but it is geared toward multiple targets all doing the same thing. So you have a list of targets. In this case, it's being used for a mosaic. It might be used for astrometric targets, or perhaps originally it was actually being used for exoplanet survey purposes, where people would put in a series of areas they were wanted to search for exoplanets. And then it'll run in a loop and go through these targets with a number of different ways to control the sequence. And then the ultimate here is drag script, which a lot of people tune out as soon as they hear scripting. This is really programming light. There's a panel of all the things you can do on the right side. You click and drag and drop into the sequence where you want that action to happen. And really, once you get your drag script set up, you probably won't touch it barely ever again. I built an all-night imaging script, and I've been running it for years now, and I've only added, I'll show you in a second what I did when Robo-target came out for automated scheduling, but other than that, I really don't touch it. But this is where you would normally do things like define waiting for the conditions under which you want to start imaging. You might have a time relative to astronomical civil twilight that you want to start before or after. You may do things like connect to your equipment. Perhaps, and one of the things I do is slew directly overhead, slew near the zenith, and then do a blind solve to make sure that my scope and my mount is in sync. And then you run your sequences, and then there's also an ability to shut down at the end of the night. In addition, within your script, you can handle weather events or any other sort of safety events. So if the clouds start rolling in, you can define what to do. Like, okay, let's park the scope, shut the dome, or roll off roof and wait until you have the clouds clear, and then you can start back up again. So very handy for this. And if you're of a mind to do so, you can actually set things up so that it will run 24/7 continuous hands-off, meaning you can, at the end of your night, shut everything down, park your scopes, close up the roof, and shut down your PC. And then I use a power switch that is scriptable from digital loggers, and it will turn off power. And then, set that to turn off power, say mid-morning, and then turn power back on late afternoon. And when it turns power back on, Windows will boot. And Voyager is set as a task to run when Windows boots, and it'll run this drag script. So you can just have that, all sitting there running hands off every night when the weather's right, and taking your images for you. So it's kind of the ultimate in hands-off automation. So that's all kind of been around for a while with Voyager. New this year, and it went into beta in January and it released mid-year, is Voyager Advanced. And this introduces a new level of automated scheduling. So the main difference here with manual scheduling, you're in control of when a particular target gets imaged. So to do that, you might have to sit down with your ephemeris or your planning software and say, well, I want to shoot M51 tonight and I want to get 100 2-minute shots of it. When is it well positioned from my location to take a shot? How close is it to the moon? Should I even bother tonight, or the moon is already, it's almost full these days. It might not be a good night to shoot it at all. Then you go into your software and you set up your night's plan. And then you may have to handle interruptions like the clouds pass by. And, some software is smart enough to know that if the clouds are done and it's clear again and you can restart, well, it's a couple hours may have passed. So what you were shooting when you close down may not be the right thing to keep shooting when you start back up again. And I've, some of the imaging software I've used that does handle all night imaging really didn't handle that very well, very gracefully. And then, well, the target's not going to be in the same position at the same time every night. So you have to redo this calculation as your target moves through the sky as the year wears on. So it's, it's kind of fun for a while, but if you're doing this for 3 scopes or 20 scopes and, across 4 seasons, it gets old because it's a lot of manual work. And it's the kind of work that as you do it, you think really a computer ought to be able to do this. And that's what Voyager Advanced can do. So with Voyager Advanced, you say, it has a database of targets. You put as many targets as you want into the database. And with that, you say, what's your desired result? I want this many shots with this filter of this target. And what are your constraints? And you might say, it's got to be at least 30 degrees in the sky. It's got to be over my local horizon. And I want to make sure it's at least 60 degrees away from the moon. And I don't want to shoot if it's, the moon's more than half phase. And with all those targets in the database, Robo-target will then compute what to image, when to image it, and it'll do it over as many nights as needed until you get all your shots. So, it's really nice to be able to just load the targets. If you're scrolling through Astrobin and you say, wow, that's a great looking target, I'd like to do that someday, rather than jot it on a piece of paper and lose it, you can go over to your Robo-target manager that I'll show you in a minute and load the target in. And when the time comes to image it, it'll get imaged. So that's nice. I've got a database full of targets, but how does the scheduler choose what to run? And the way it works is it'll go through all the targets in your database and it'll look at your constraints that you've set, and that will create a set of eligible targets. So these are the, whoops, I'll go backwards here. So these are the targets that could be run at this particular point in time because they meet the constraints. Then it uses a scheduler algorithm to choose among the eligible targets which to run next. Today, there's one scheduler, and it has really 2 filters. One is priority, so you can set from 6 different levels of priority for your target. And then from that group, it picks the oldest in the database first because it says, okay, well, that's the one that's been hanging around the database the longest, so we'll try to get that one done. There's also a couple of sort of interrupt type functions called a preset time interval and one shot. And these are for cases where, regardless of everything else, you absolutely want to run this one at a particular date and time, or between date time Y and date time Z. So this is handy if you have an astrometric event that you want to do tonight, or if you need to use the system for something like a live demo, you could set in this function and take over the scope at that point in time. The architecture of Voyager Advanced is such that it's easy to add more schedulers. So Leo has told us, as users provide input on different algorithms like soonest to set, highest elevation, least time left to run tonight. Those can get added to Voyager Advanced. So I mentioned earlier that I have this all-night drag script that runs my observatory. And before, I had a block in there that ran my sequences. So I had to go to a sequence and edit it to include the target I wanted to run, and maybe change my constraints. And to change that to use Robo-target, I basically replaced this block with that block, and that was it. So there's literally one call to Robo-target, and then just handling 3 different error conditions, skipped, an error, and a timeout. And the details are not relevant here, but you can see very simple to handle these 3 errors. And that's pretty much the way you're going to want to do it. So it was very simple. I was actually kind of shocked back in January when I got the first beta build of Voyager Advanced, and said, oh, what the heck, I'll go for it, and loaded it up on my observatory, and by gum, it worked. So let's take another poll here now, Christian, and this one is about, would you like to run your setup all night unattended?
Yes, one sec. I am just looking for the poll.
I know some people like to sit by their scope and watch things roll in, and other people like me like to sleep. So this is also an excuse for me to take a sip of coffee. So.
Okay, there we go. It's all on. Yeah, and whilst we're running this poll, I just wanted to add something that is really worth showing is for the mosaic. You showed the research panel is really the beautiful and often a bit hidden web interface, because I use it, and it's just so simple to make a mosaic out of it. So
yeah, good point. We'll bring that up.
Yeah. Okay, we'll give it a few more seconds. Yeah, there you go. That's it.
Yeah, so there is a web interface, as well as, of course, if you have a VNC or some way to, Google Remote Desktop, your favorite way to connect to your remote PC if you are running remote. But from the web interface, you can do most things. So self-filtering audience, I guess. A lot of interest in running this way. So that's great. Good to see. A lot of people like to sleep like me. I remember way back in college when I was debating between astronomy and software as my career choice, and sitting in the observatory in January at 2 a.m. versus sitting in the nice warm computer center. So anyway, nowadays we're a lot more automated than back in the days of film. All right, so just a quick look at the web interface. So you can do most of the things that you need to do to run Voyager from this web UI. And one of the nice things that Christian just mentioned was this planner. So you can look up a target. So here I've got SH2 Sharpless 2 64 loaded, and you can either in this case it's set up to run a single frame, but you can also say, I want to run a 2x2 mosaic panel, and it's basing the size of these on the system that it's currently connected to. So the current Voyager system that I just connected to has this particular field of view. So now we've just defined a 2x2 mosaic. So I pan around and decide what I want to do. Then I can go into the RoboClip database. So this is separate from the Robo-target database. This is RoboClip. So here's a place where you can just store all of your targets and then easily add them to a sequence or add them to the Robo-target database. So I can say, get data from the virtual field of view, and it pulls in the mosaic. Since I panned around, it's not sure, if I'm still talking about the same target or not. And then I can save it. And that saves it to the Robo-target database, where I can then add it later to to a particular sequence. Now you can, today it is supported to add all the panels of a mosaic to the research and survey mosaic sequence type that I showed you earlier. It's not yet supported to just automatically import all of these into Robo-target Advanced. But that is on the request list, and it's a highly requested feature.
And one thing I'd like to add, which I really like also, it remembers the rotation angle of the camera, which is very good because, for example, if you use Nina, which I also use quite a lot, it doesn't remember it for whatever reason. At least I've never found it. You have to always ask it to take a picture and calculate the rotation angle, whilst here it remembers your last one and the position angle, which I think is good because you can plan off, when your telescope's not connected.
Yeah, that's a good point. So yeah, if you have multiple profiles, and a profile is where you store all the information about your scope and your camera and so forth, you can select the profile, and that may change, the view. And as Christian just said, it's also going to remember the PA. And if I want to change the PA, I can also rotate it somewhere here. Over here.
That's where it is. Yeah. That's it. That's the size.
Over here. There we go. Angle, yeah. So I can also change, the PA, and that'll get saved with my target. All right. So we'll go back. I think we're about almost done with slides, and we'll go back to the demo. All right. So we're going to go through a demo. So I'll go through, setup of Robo-target. We'll actually show them the manager where you add your targets, the runtime interface, how you might use it to connect to remote scopes, especially if you have more than one, and then the reports that you can see, results, statistics, the ability to rate your images, and a PDF report as well. So let's switch out of good old PowerPoint, and we'll bring up the Voyager that I have running. So this Voyager instance is running on my local PC here, and it's connected to the SkyX running simulators. So I have a camera simulator running, a mount simulator, the SkyX planetarium, and also the SkyX plate solving. So this lets me do a demo here without having to worry about the weather and things like that. So first thing I was going to show you was the local horizon feature. So, we don't all have perfectly clear mountaintop views with, 0-degree horizons in all directions, sadly. So you have the ability here in Voyager to define your local horizon. So this happens to be what my local horizon looks like for my observatory. And to define that, you can import a local horizon, because a lot of people have already defined this either with the astrophysics software, CART to SEAL, a generic CSV, or the SkyX. So you can pick a CSV file that you've already, that was an interesting one, and apply that. Let's see. Doesn't really matter here. I'll just cancel. But it's a simple CSV file where you have for each degree of azimuth, you can put in an altitude below which you don't want to image, and then you apply that, and then that becomes a built-in constraint for all of your imaging. A second interesting thing that we've got here is a moon avoidance function. So depending on the filter you're using, narrowband filters, you can get a little closer to the moon. Wideband filters further away, broadband filters further away. And at different times of the month, when the moon is at a different phase, you may want to get a little bit closer. And setting all this up, in a lot of software, you can just say, well, stay 60 degrees away from the moon, period. But the Lorentzian function, which was researched by a group out at Berkeley, lets you define a graduated distance that you want to be from the moon before you can take an image, and it'll change based on the day of the month, which corresponding to the day of the moon phase. So this is set up in terms of a distance and a width, which are not super intuitive what those means, but the distance is the maximum separation from the moon. So this would be when the moon is full. And the width is the number of days in sort of half of a cycle. So for the moon with the 28-day cycle, you generally want to use 14 days. And this width would be your maximum separation on a full moon. So for broadband, it's 120 degrees by default. For narrowband, it's 60 degrees by default. Or you can go in here and just create a custom separation for whatever you wish to use. So I generally just use the defaults. I think Christian said he has a custom one set up.
I use quite a risky,
Okay.
yeah, so I do, yeah. Yeah.
You've got a very long dew shield. Huh? All right. So that's the moon avoidance. So that's nice. Just like before, I showed you the on-the-fly panel in Voyager. Here's the drag script panel where you can create your script. And then there's a Robo-target panel. So in this panel, whether you call Robo-target from the drag script or whether you just run it interactively, there are a number of settings that can be applied. For now, as I said, there's only one scheduler type. So the default scheduler is the default. You can also tell Robo-target how many minutes before or after the start of astronomical, nautical, or civil night you want to start and end. And then there are a series of more advanced settings. And one of the features within the Robo-target scheduler is to set a maximum amount of time that any one target can run. So you don't have one target, hogging the whole night if that's really not what you want to do. But that means you might reach a point where everything's run. Let's say we said nothing can run more than an hour. Everything's run its hour, but you still have, night left. And this says, okay, go ahead and run targets that have exceeded the maximum shot time per night if there are any available. And there's nothing else to run. You can also define the shortest time that you want to run a sequence, so it won't even bother if it's not there. You can define your moon down altitude. So, you might think, well, isn't the horizon moon down? Well, there's still some moonlight. If the moon's full and it's, it's bright, you're still going to see it. So you might want to go below the horizon before you consider the moon to be down with your constraints. There's also some soft retry capabilities. So this says if, sometimes things just are a little flaky and they may not work perfectly the first time. If you have a soft error, like maybe an image download from your camera doesn't work the first time, you can say, go ahead and just retry it up to 5 times. There's also, for a sequence, the maximum number of times you want to retry if there is an error. You can also say, if you're in the meridian flip zone, just don't even start running a target until we finish the meridian flip. And then the final part here is to create optionally a PDF report, which tells you all about the night. I'll show you one in a bit. And you can even have that emailed to you. So that's nice to just wake up in the morning and check a report to see what happened. So those are the global settings for Robo-target. So let's take a look at the manager. So this is where we put all our data in. Let's see if maximizing this. Yeah, that's pretty good. So at this point, I'm actually connected to one of my scopes out in the observatory. We'll see if that's, I want to show you the local one because that's what we'll run in a second here. So I'm foreshadowing here. You can actually connect to multiple setups that are running Voyager that I have there. 1 local running simulators and 3 real peers. I'll just connect to the local one for a minute. So you can manage all this. The nice part here is I don't have to run out to the roll-off roof or switch between different Google remote desktop screens to manage my database for the scheduler. I can do it all from one screen just on my home PC. So this is the local one running with the simulators. So at the top level, we have the Voyager node. I also have profiles. So if I had set up multiple profiles in Voyager, and this is something we didn't go through today because it's part of Voyager Basic. As I said, this is where you would define the scope. Let's say you change your camera on your scope periodically. You would probably have more than one profile, one for each camera. And then within each profile, you can define as many base sequences as you want. So as you recall, we looked at the sequence earlier, and it has, I'll show you a sequence here. It has all these panels that define things like, exit sequence if target is below this altitude, run a program before you start your sequence, cool the camera to -25 degrees. How many times do I want to retry pointing if I have a failure? Manage the rotator, tracking, plate solving, blah, blah, blah. So it would be kind of tedious to have to do all these things over and over again in the Robo-target database, but fortunately we don't have to do that. And what you find in reality is, you might have a couple of different configurations of the sequence that you use. And by defining these as a base sequence, most of those properties, except the shots defined, will automatically be used for your Robo-target targets. So then within that profile, you can have sets of targets, and you can create as many of these as you want. And one of your fun exercises as a new Robo-target or Voyager Advanced user is deciding how you want to organize things, because it's really up to you. I have by object type, because frequently I may have a set of shots that I want to take for a particular type of object, duration, the exposure length, and so forth, and the targets that you then have defined to run within that set. So we have, in this case, M31 is set up. Let's say that we wanted to show you how to do this from scratch. So I'll remove this target. And I happen to know that with my simulated time here, which says it's 9:40 p.m. locally, M31 should be well placed that we can run it in the simulator. And then I can take my default. So I created a dummy target here, and I just copy it and then paste it with all the slots. And now I have created a new target in the database. And at this point, really all I need to do is add the coordinates and check that the constraints are what I want to use, and I'm done. So I'll show you what how that looks. This tells me that this being read is to really call your attention that this target's currently not enabled. I enable the target, and I got to move my zoom images here out of the way so I can see. And I could pull it out of that RoboClip database that we added to before. So I've got a number of targets that are defined in RoboClip. So again, these might be things that, as I said, you see a great target on Astrobin and you throw it into your RoboClip database. You can pull it from there. Or I can use the planetarium. So I'm connected to the SkyX. So if I search M31, there we go. I say use that. And now I change my target name to M31. And my coordinates were pulled in from the SkyX. And in reality, at this point, I would just say apply. And I'm now added that target to my database. And when M31 is ready to run, it'll run. But there's also, here's where we set up the constraints that tell the scheduler and tell Robo-target when it's okay to run M31. So I have overall a set of priorities. So among all the eligible targets, I can make one to be first absolute top priority. I really want to run this tonight. It's a new target. I just added it. I'm excited to see what it looks like. Or I can say, this is a fill-in target. I really don't care that much. So just run it when nothing else is good. But, I'll leave it at normal priority. And then one by one, I have a set of constraints here. position angle. So I can say I want to use a position angle for this target, or I don't. I don't have a rotator in this simulator, so I won't. I can choose a minimum altitude. So don't run it if it's lower than 30 degrees in this case. If I have a sky meter that tells me about sky quality that night, I can use that for a constraint. One I use a lot is hour angle start and end. So this says run it 2 hours before and 2 hours after its transit. So I know at that point it's about as good as it's going to get at my location. So I don't even have to worry that much about minimum altitude, because I might have a target that never gets higher than 30 degrees and I still want to try it. You can set a date start and end for your target. So if it's a seasonal target, moon down. So you might just say, forget about the moon distance. I just don't want to run this at all, if the moon is up. I could also just go with moon phase minimum and say, moon is down, or if the moon phase is less than 20%, run this target, both min and max. And now, so I actually created this default before the Lorentzian came around. I would probably use the Lorentzian nowadays and pick from broadband, narrowband, and the free setting is the custom one that you saw in there. You say, or moon down. So this is what I use today with my own targets for the most part. HFD submax. So after it takes an image, it's going to do a check on the half flux diameter of your targets. And if it's a really crummy seeing night, you might say, just forget it. It's just not good enough to run this target. Here's where I mentioned before, there's a max sequence time for the night. So I might say, run this one for 60 minutes and then forget about it. Go run something else. Max sequence time is not just for the night, but for all nights. And then some people like to think in terms of air mass. So at 30 degrees altitude, the air mass that you're shooting through is double what it is if you're shooting at the zenith. So that's yet another way that you might do it. So since I'm going to run this with the simulator, I'm just going to turn all these off because I just want it to run so you can see what it looks like when it's running. There's also a couple more tabs here. Slots repeat. So within the sequence, as you saw before, we define the shots that we want to take with each filter, how many times we want to take a shot, but you can do a multiplier over the whole thing here. So let's say, I have a sequence set up that runs for an hour. I might say for this target, I want to get 5 hours of data over multiple nights. Finish actual exposure says don't abort the sequence just because one of the time limits were hit. Go ahead and finish the running exposure before you quit. Wait before shot might say I've got a settling time for the mount. I just want to wait 10 seconds or whatever you choose. Cooling set point. If I want to cool my camera to a different setting that's in the sequence, I can do that. Or I can change my guiding camera exposure time from here. There's also two sort of override everything settings. Target one shot says this is a target that no matter what's running, I want to take over the system and run this target tonight. So a one-time event, something you want to capture, especially, you can turn this on, and unless you've got another one shot already running, this will run. And similarly, there's an interval. So rather than just saying tonight only at this time run it, you can say between this date starting and this date end run this target. So these are some overrides that have been requested by some of the remote observatories. So that's the way you would set up a target in Robo-target. And I say generally you don't change these very much. You might have one set for broadband and one set for narrowband targets. So generally I pull something in from RoboClip after setting it up in the Mosaic and the web interface that you saw, and just pull it in and click apply, and that's it. It's now added to the database, ready to run. So let's take a look at the runtime. So we go back to the manager. So I've already run this afternoon, just getting things set up here. So I've got some data already in place. If I want to run Robo-target interactively, all I have to do is click this button. And it did not like any of the targets there. Oh, I know what happened, because I'd made a change to the database. Let me stop and restart Voyager. It will actually find them, but this will be faster. So I'll connect to my simulators here with the connect button. So one by one, if you see green here, that means all is good. If you see an error message here, time to start unplugging and replugging USB cables. And now, so now I've got, I clicked run Robo-target, and it's done a couple of things. The first thing that it did, okay, this is interesting. Maybe my local time on my PC. Yeah, it doesn't want to run this. So let me explain the ephemeris here. So for each of my targets, it's gone out and done a number of calculations. If you look here, the cyan curve is the altitude of your target over time. So the x-axis on all of these is time for the night. So you can see this M42 is starting to rise pretty shortly. The orange line here, I'm sorry, the yellow line here is the moon elevation during the night. You can see by the icon of the moon that we're dealing with a almost 80% full moon right now. It just redid its calculations. It does every 60 seconds. It'll look for a new target. The red area for each ephemeris, that's the area where none of the constraints, or the constraints were not met. All the constraints were not met, so it can't run that target. The black area here is where the constraints are met. So you can see we're really getting close to where M42 would be an eligible target. The orange line is the azimuth of your target throughout the night. The purple line is the distance from the moon, so the moon separation. And I think the last one is this magenta line, and that's the moon phase. So you can see we're really getting close on full moon phase here. So I'm curious, I've done something goofy with my my M31, I think, because it should be running. Let me see if I can get M42 going by changing my computer time.
Computer time, maybe you get it.
Yeah, this will be, this is hazardous duty here, folks. Changing computer time in the middle of a webinar. Let's go back. Well, let me go forward in time and see if
1 hour would do it, I think.
Yeah.
We restart.
Yep, that did it. All right. So it's now, if you look here, there's a log of all the actions that are taking place. So it is, the simulator is slewing to M42. It's taking a plate solving exposure, 1 second exposure, which it downloaded. I know my, the way this is working in the simulator is it's downloading the deep sky survey data, and then the SkyX is plate solving that. It has varying degrees of success with plate solving deep sky survey data. I know that it can successfully plate solve M31, which is why I picked that guy earlier. I may actually, when it takes this long, it might just be, yeah, it's having trouble. So the SkyX is not able to solve the little deep sky survey image that it downloaded. And
I actually found that ASTAP does a better job there, but
Yeah, it is good. I looked earlier today to see if I had ASTAP on this machine. I don't have it on the machine. Let me try going back a little earlier, like let's see if it'll do M31 after this. It's going to wait for this blind solve to return from the SkyX. And let's see what we got here. Come on. No. Well. All right. As the saying goes, it worked earlier. And Christian is my witness. I showed him working. So.
I know all about live demonstration. Always like
okay. Well, here this could be it. I think I've got. Yeah, when I re-entered M31, I didn't click apply, and I added a bunch of constraints. So I had M31 in the database earlier with no constraints, so it would run. And I think because I added the constraints. Yeah, that was it. So I had to take the constraints off of my M31. So now it's slewing to M31, and hopefully the SkyX will succeed in solving it like it did earlier. If not, yeah, it did. So it solved. I can show you what it's looking at. So this is that's the deep sky survey data for M31 that the SkyX camera simulator downloads and solves. And now we're off and running. So we're taking exposures now of M31 with the simulated camera. And it'll keep running there. So I will stop that. I'm curious, because I just made changes. I might, oh, okay, it came up. But yeah, the ephemeris data, because it's a lengthy calculation, it does not keep doing that over and over again every time you start running. It'll do it when you start Voyager for the first time. So I'm not going to mess with it right now. You saw the data before, but it will normally calculate that ephemeris data and show it to you as it's running. Actually, maybe it's worth doing. Let's see. We'll shut down again. But if you change your database, it knows it has to recalculate it. And we'll start Voyager. We'll connect.
Yeah, by the way, just I think it's very good that you showed how quickly the constraints can kill a target, right? So
exactly.
For example, with air mass, you have to be extremely careful, because if your target's not high enough, you'll never, you might put in the wrong air mass. And
exactly.
So be very careful when you put your constraints in.
Yep. So now, I restarted it. So now it went ahead and recalculated these ephemeris images. And you can see here, one other change that happens, your currently running target has a blue background, whereas the eligible area is black. So this one turned blue, and we can see M31 is getting very high. It'll be at transit in a few hours by my messed up PC clock. And over here we have the blue indicating this one is running. This one was suspended, and it's suspended until, and it gives you the time, 23:25. You can remove a suspension, and it'll become eligible after M31 finishes running, but it still may say, oh, it's still suspended. So sometimes you'll get a temporary suspension where maybe the plate solving failed, and you can go in here and just remove that, and it'll reconsider it in the scheduler. So normally, again, this is this is a way to interactively run Robo-target. I don't usually do this because I just run my drag script and it will do all the magic for me behind the scenes. So that's the dashboard.
Rowland, just very quickly, because I had this also, where it says schedule candidate interval invalid. That put me off, that statement, and now I see it in yours too. Why the word invalid? It's
so I'm not 100% sure.
Because I thought I'd entered something wrong. That was my conclusion.
Yeah, no, it's not entered something wrong. Yeah. I think what it's saying is that the interval of time is not currently met.
Yeah, maybe it would be a better formulation for that.
Yeah, yeah.
Okay.
So, English is a second language.
Yeah.
So let's see. I also wanted to show you the remote JPEG viewer. So there is I don't know if this will work. If I connect with the web interface, this will probably look horrible. Well, yeah. Unfortunately, we're using this deep sky survey data, which is already stretched. So when it gets stretched twice, you just get a white image here. But normally through the web interface, you could see the last image taken, as well as all kinds of information. Your activity log is in the web interface. Image statistics in terms of HFD, the star index, which is a metric of how good quality your image is, how many stars are being seen over how many are predicted. So a higher number here is better. We're not auto guiding with the simulator, but you would see your auto guiding graphs over here, focuser information, progress through the current sequence. There's a lot of good information in this web interface. All right. So back over here to Voyager. Let's stop the current sequence and we'll go back to the manager. And we'll connect because we quit and restarted. I'm probably going to want to go, actually, let me go to one of my live scopes and show you one of my awful images here. This is really brave. I'm showing you, I have no idea what I'm going to show you here other than this is what came out of the camera. So if we pick, all right, so going back here, you see a couple of icons we haven't talked about. In addition to the individual targets that each have their own section here, we have for each target the shots that we defined. I don't think I even went through this in any detail, but you can have as many here as you want. This defines a number of filters. For each filter, the number of exposures, the exposure length, and so forth. And if you have completed shots, let's see if we can find this. This one says 95% completed. So hopefully we actually have something here to look at. So here's all the shots that got taken for this target. And for each one, we have the filter, the exposure length, HFD, star index. So these were pretty good. That's a higher number. Your flux, mean, min, and max, a rating field we'll talk about in a second, and then the fit image. If you want to see the image, you can right click on it and it will download a stretched JPEG. So especially if you're operating remotely and over a kind of a slow connection, it's handy to be able to look at the images this way. So all you're pulling is the JPEG, not doing a whole remote screen operation. So that's available for all your images. You also have a summary. Well, if I come back here. This is useful here. So there's a summary by all the sessions. So this says for this torus molecular cloud target, I currently have accumulated 21 hours, 38 minutes, and 27 seconds of data. I'm 95% complete. And this happened over 5 nights in October and November. I could also click on any one of these and just see the shots that were taken for that particular night. And if I wanted to look across all my targets and all my runs, so this says since I installed Voyager Advanced back in January, I had 67 sessions. And I can look at any one of these sessions and I'll see the targets that I ran that night. And just like the table for the individual targets, I can look at the data for the target. I can pull down a preview and generally get a nice overview of what's happened. So that's available from the manager for all your scopes that you can connect to. And two more quick things to show, and then I think we'll open it for questions. There's a column here called rating. So some people, the way I normally, my normal workflow is to run everything. As Christian and I were discussing earlier, I use a software product called Siril, S-I-R-I-L, to do the calibration of all my images. And once they're calibrated, I load them in PixInsight because it has a pretty fast blink function. And I blink through the images and decide which ones I don't want to use. That's my approach. A number of people ask Leo to provide an automated rating interface. So several ways that you can rate your images. You might be sitting there in real time watching them in the viewer and rating them. You can right click on the rating column, pick a rating, higher is better, and say, gee, this one was a 10, and apply the rating. And now this particular fit is set up with a 10. I can apply the same rating again to here, and so forth. Or I can export this whole table to a CSV file. So Taurus CSV, and then I could load it in Excel. By the way, this is a great little search program. It's faster than Windows search and it's free, called Everything. I don't know how I made it without it. It finds everything on your hard drive. And now I've got all that data in an Excel file. And in addition to the data that was in the path, there's a rating column and a is to delete column. So that's the rating. Let's see, I had my 10s and my 0s. Actually, I would like to import this as an Excel spreadsheet. It would be easier to read. But I can change in the CSV file the ratings, and I can mark something to delete if I don't like it. And then I can load it back into the manager here, and it will hold on to that data that I just changed. There's another way, and this is, I think, what the people who asked for this are mostly using, through a set of programming APIs to connect to the Robo-target database and do an automated rating. So you can read out the data about the HFD and the star index and mean, max, whatever. And everybody has their own pet algorithm as how they wanted to rate their images. And then they can apply the ratings that'll be stored here in the Robo-target database. The Voyager itself does not currently do any ratings of images. That's either you do it manually or you do it with a piece of software you wrote and you use the APIs to save that. And so what good is that? Well, you can then, you notice there's a tab here called deleted. Currently there's nothing there. Voyager will never actually delete a file from the hard drive. So deleted is just a status that says, delete this from the count of images that I'm trying to take of this target. So let's say, we just had a bad night, seeing was bad, maybe it was hazy, and you took 30 images of the 100 total that you wanted, and you really just didn't like any of them. and you said, this was a loss, but I don't want to go back and redo my target and say take another hour's worth or another night's worth of images. So all I could do is say, well, just this night was a loss, delete them all, and all it's going to do is it's going to move them over to this tab, and it'll reset the count on your target so that it goes and takes these again. If you say, oops, I really didn't mean to do that, you can also restore and move them all back. Or you could say delete by rating and say, I want to delete everything that wasn't a 10 and apply it. And now, I didn't see that. Oh, I forgot. Yeah. A rating of 0 means it has not been rated. So if I change this to a 1, and then I did that again, then that 1 got moved over to here. So if I had an automated system set up, and I'd, in my own algorithm, less than 10 was not good, and I had a bunch here that were 7s and 6s, and then a bunches that were 10s and 15s, I could use this to just move them all over at once. So that's the rating system. And the last piece I want to show you is a PDF report. So another way to get a quick sense of how the night went is to ask Voyager to automatically email you a PDF report of the night. So this is one from last night, and I have 3 of these in my inbox, one for each session. It shows aborted because last night, let's see if I can find it here. I got my Zoom bar is preventing my seeing my tabs here. Okay, so there's my cloud watcher from last night. It says, yeah, this session got aborted because the clouds rolled in and the observatory closed down. So that's the point at which this session was aborted. Just for record, your settings, they were way back when we looked at the settings you can create for Robo-target. These are the settings that I had for the night. This tells me that I had a sequence that ended when plate solving failed, probably because of clouds. I did have a successful session on NGC 1535. And then here's all my data that I got from those successful targets run. And here's a target that did not complete because of the precise pointing failed, meaning plate solving failed at that point. So it's nice to get these reports in the morning, just to get you a quick sense of how the night went. So there's a lot more we could talk about, but I've been talking a long time. So Christian, maybe we should open up for questions so we can handle any directed things that I missed.
Thank you very much, Rowland. I mean, I learned quite a few small tricks there, which
Good.
I wasn't aware of, sort of hidden things, including the report. So that was great. Thank you so much